So my name is Aydin from Penn State. This is a PhD student work. Natalia Kosilova is one of my students. And also joined with Andrew Vakhutinsky from Oracle Labs. And the title, it says Optimal Upselling. But you actually know the context already because Pelin did a beautiful job introducing standby upgrades. And that's exactly what I'm calling upselling, okay? And the work I'm going to present essentially develops a discrete choice model to understand consumers' choices when they are faced with upsell offers, right? In some sense, there's a great overlap with the first paper that you've seen. So I'll tell you where we are. It's kind of work in progress. It's one of the dissertation chapters that Natalia is working on. In the interest of time, I'm going to skip the slide because you booked a room and you are offered multiple upsell options. You're basically essentially given the opportunity to buy a more quality product at a reduced price compared to what you've seen originally, right? And there are multiple offers made for a single customer. And it is also true that in general, in the company that provided this data, Nor1, they do allow customers to choose multiple of these offers. And I'll tell you how we deal with it here. So what is our research question in its broadest form? What is the optimal upsell strategy from the firm's perspective? And to answer that question, of course, one needs to understand how consumers respond to these offers, right? But we have this sort of decision theoretic sort of view from the company's perspective, whether to make upsell offers or not, right? Which products to offer for upsell. I'm going to call that assortment decision, so to speak, quote unquote, and at what prices, right? So that's the broadest question that our research falls under. Did we answer all of these questions? Probably not. Yes, Brad.
So I'm just curious, can't you add like entrance fee for the customers to even being able to see this standard upgrade offer?
One could. This company doesn't. So Nor1 actually sells their services, the data analytics and consulting and all of that, the software, to hotel chains, right? So they help them figure out exactly this strategy, like what price, what hotel rooms to offer in the upsell offer, right? And that's it.
So at this point, it's free actually to go to the standby deal, so you don't need to pay even like $1.
For the consumer to see, correct.
And be added to the standard.
What do you mean?
Yeah. So
yes.
Right?
Yeah. Could they charge? I don't know. So there are a few directly related papers, right? There's modeling work by UTD folks, Çakan Yıldırım and others. Of course, Övünç Yılmaz and the team, they have by now 2 or 3 papers, right? And there are other papers related. So I'm not going to spend too much time on the literature if you excuse that. Dan?
I just have a question. I think about this entire problem.
Yeah.
It seems to me that everyone is talking about offering this upgrade at the time of purchase.
Right. After purchase.
Right after purchase.
So you booked a room, you gave your credit card, all of that.
Yeah, I guess my question is, maybe this is already done. This is just a naive question.
Here?
Yeah.
Oh, further. Okay. so gather people were thinking I disappeared.
So
go ahead.
Did anyone thought about the temporal aspect of this, of when is the best time for me as a hotel to offer this upgrade instead of offering this right after purchase?
Yeah.
Maybe there is a best timing at some point. Let's say someone booked the room 3 weeks in advance.
Yeah.
Maybe I will observe what happens with my bookings at some point throughout those 3 weeks. Maybe there is a best time for me actually to upgrade. Is that?
Yeah. So good question. The only paper I think that touches on this is the first one, Çakan Yıldırım paper. They have a dynamic model. It's I think 2 categories only, if I recall correctly. But by and large, the timing question has been left alone so far. And for my talk, for the purpose of my talk also, I'm going to ignore that. But that would be an open question. It's a nice question to ask, actually, because people who book well in advance, They may have different willingness to pay customer characteristics compared to people who book in the last minute, right? The classic revenue management considerations.
I'm actually more thinking about, let's say that let's say that someone booked the room, and after some time observed I have another premium room left, then I would offer those standard upgrade.
I
But
see.
if my premium room are already sort of booked, there's no point in me doing that. Even if
Right.
the people, the guests accept that offer, I'm not going to make more money because I wouldn't be able to assign to fulfill that upgrade.
Agreed. I think there's a lot of potential in the dynamics of this problem, and by and large, most of the literature is at the, I think, what you would consider sort of static problem.
Sorry, just one
Red.
more. I don't know. So it seems latest is always better.
I'm sorry?
So latest is always better. As the hotel, I'm always better off to wait until I have
The last
less-
minute?
Yeah. Why should I offer this right after purchase when I can wait?
So speaking as the product owner, guests behave differently. So not everybody thinks that way. So one of our best performing exposure points is immediately after booking. So we have the data. So we, Nor1, Oracle, we have that data. It's just never been studied apparently through these papers. But the data exists, and we find that guests behave not in the way you describe.
There's your strong answer, right? That kills the discussion. What do we expect from a choice model to be reasonable, right? So we want, if the offer has a more expensive price, we want the probability of acceptance to be lower. If offer is more expensive, if a given offer is more expensive, the probability of others being accepted should go up. There are substitution effects, right? That's why discrete choice modeling would be appropriate in a context like this. And you also want from your price optimization reasonable answers, as in the optimal upsell price should be higher than the price of the originally chosen item, but lower than the price of the premium item that you're upgrading to, right? So those are just some things to think about. In the interest of time, I don't need to actually illustrate what my model is about, because you've seen from earlier presentations what upselling is about, right? So there's an initial choice, J, and you're offered a bunch of upsell options that are priced higher, and then your decision is whether to stick with the original choice or upgrade to one of those K upsell offers, right? For this crowd, I don't need to say anything about MNL. But our model is going to be based on MNL, so therefore independence is there, right? For example, if you have a $50 room booked, and there's a premium one that was at $100 price point, you could be given an upsell option for $80 for that room, right? And then the decision is, do you stay with the 50 or go up to 80, right? Okay. So if you assume logit for the initial choice, as well as if you assume logit period for the utilities, right? So deterministic component plus a Gumbel error term, what is the conditional probability of accepting an offer if there's only one single upsell offer? And that's the formula here, right? And that's where we started. That's where Natalia started her dissertation work, and she was excited to find this formula. And then in reality, she then figured out there are multiple offers given to customers. So later, so you may have seen this version of the talk before. Later, she extended that to multiple offers. And if you have a single offer scenario, right? So each customer is now getting just one single upsell offer. Optimal upsell price can be easily done, and that's so I'm not going to present too many formulas here, but there's an implicit equation that you need to solve, and you can find the optimal price very easily. And also in a mild sort of special case with a mild assumption, I can also tell you that in this setting, you would offer the most expensive product for the upsell. So that also solves the assortment question for the single offer case, right? If higher utility items have higher prices, which is a reasonable assumption, then you would offer the most expensive product. Of course, many of you who dealt with real data and have seen how real hotels operate, they may not actually like this all the time, right? Because maybe for this particular customer category, the most expensive option would be just out of their reach, and they would not even they would laugh at the offer, right? So, but with some maybe segmentation and things like that, this result could be still useful. I'm going to spend more of my time on the multiple upsell offer case, not really with formulas, but on the estimation side as well in the remaining time. So suppose the prices of K items, these are premium items compared to what you chose initially, were lowered from their original prices to a bunch of lower prices, right? So P1 star, P2 star, PK star. What is the upsell acceptance probability in this case, right? So we have a tractable choice probability development, and I'm not going to present the formula because it's just too long, and the proof is pretty tedious also. And those tractable choice probabilities give us a tractable upsell pricing problem. When I say tractable, that's kind of on our wish list because the single offer case is quasi-concave, therefore it's easily optimizable. This one is not. So we still don't know fully all the structural properties of this problem, and it's in the scope of the dissertation that eventually, hopefully, we'll figure this out, right? So in this case, how do you optimize prices is still open. Right.
When you think about optimizing prices,
yeah.
These prices may not be actually paid to the platform because eventually the standby didn't have enough space for the person to get the room, right?
So you mean hotel, right? Not platform.
The hotel.
The hotel.
I call it platform.
Right. So our research really stops at what NOR1 recommends to the hotel.
Right. But then when you think about the revenue objective, then that price might not be collected by the hotel because the room is not going to be given.
Right. So after the fact.
There is a difference between assortment and here. So in the assortment, when the customer chooses the product, the revenue is going to be collected by the assortment planner. But here, the revenue is only going to be collected if eventually the room is going to be given to the customer.
Correct. But they will honor the price though.
Sure. I mean, I understand the choice model from the customer.
Yeah.
I'm just saying when you think about optimizing for prices, since you are sitting on behalf of the hotel.
And are you talking about the initial prices or the upsell price? Initial upsell prices.
Yes.
Okay.
There is some early disconnect here. I think you are right. If you choose something, doesn't mean you do that. So it's not exactly the revenue that you see here will be collected, right?
But
Yeah, in some, so post-COVID, behaviors are changing. And we are offering fewer and fewer, we're automating the guest is committing to the offer earlier, only because hotels are suffering from the staff shortage. So now a lot more of the offers that are presented to guests are actually, they commit to them. And the hotel agrees to it.
I guess my concern was why should I optimize for revenue that I'm not going to have?
that I may not get.
Yeah, but we also take that into account. So we know.
So it matters somehow.
Yeah, so the data, in the data, we also
It is like
know.
you can say it is positively correlated with the actual revenue you're going to collect.
That's right. So we
It
have that.
can act as a say.
Yes, so there is like will be some percentage, like think about
Yeah.
fixed percentage.
Let's say if it's a fixed percentage, it's the same.
Yes.
Sorry for interrupting.
That's all right. So what are some of the patterns that one observes in the optimal prices, optimized by just numerically? So if initial prices, so we suspect initial prices and upsell prices should go in the same direction, and we're trying to prove that, and we have many examples of that, and you're seeing that happening here, and we think also the discounts also go in the same direction. So both the amount of the discount and the final upsell prices go in the direction of initial prices. Makes a lot of sense. It seems hard to prove, and Natalia is going to keep working on it. So conjectures, the two conjectures that I already told you about, these are relatively strong conjectures. We looked at a lot of different cases, but obviously we don't have a proof yet. And as I said, the price optimization structure for the multiple offer case is still open. We have a wonderful data set. Well, I should say Natalia did an internship at Oracle Labs, and that's how she was able to access a data set from NOR1. So these are actual offers, the offer set, whether the customer requested an upgrade or not. And we are looking at what NOR1 essentially conceptualizes at stage 2, right? So stage 1 is clicking. Stage 2 is whether to request an upgrade or not, possibly multiple. And stage 3 is hotel decides whether to actually award the upgrade or not, right? So we're looking at stage 2, which is where our discrete choice model is also built around, right? And less than 5% of all the customer offers were accepted in this data set. And just on the topic of multiple upgrades being requested at once by the customer, we purposely picked properties where this was rare, just to be able to see how the estimation would work. So we're going to ignore the fact that some customers may be choosing multiple offers at once, requesting multiple offers at once. It's a classic sort of log likelihood maximization scenario. For at least trying to understand how well this model would work on real data, we tried 5 different models. I'll give you some detail so that you understand exactly sort of what's being done. First of all, what is a good benchmark using just MNL and no mathematics on this conditional probability of accepting an upsell offer or not, right? A good ad hoc MNL model would be the one at the top, which is the utility, which is like a very simple form utility, right? U minus beta times price, right? And we are not using really property categories, consumer characteristics, and all of that. So this probably could be improved a lot. Alpha times whether J was the initial choice or not, because people tend to stick with their initial choices. Right? And as I told you, 95% of the people actually did that in the data that we have. So an ad hoc MNL model would basically take the utility and just add a positive term for the initial choice. So that's one of our benchmarks. The second benchmark is MNL with positions. And by position here, I specifically mean the position in the list of upgrade offers. And again, this is behaviorally true, and I'm sure you've seen this in the retail setting also. The higher the thing is in the list, the more likely that people accept that. Okay? So that's why you're seeing gamma times position, right? Another ad hoc benchmark model. What I call exact here is the ugly formula that I didn't show you, right? Multiple upsell offers. What is the probability that a given consumer would accept a specific upsell offer? If you use the exact formula, that's what I call exact. And we have this approximate version of that, which I didn't explain it to you, but it's basically simpler formula, and it works just about as well as exact. And finally, we have the approximate with positions. All right. And here, there's a bit of a problem adding this negative term with positions, because if J, the thing that we're thinking about, the upsell offer that we're thinking about, if it was not in the original, if it was in the original offer set, right, it would be it would have higher utility. So we're adjusting that. All right. And here you're seeing a version of mean squared error, Breer score, and in property A, MNL with positions did the best. Property B, approximate, which is our discrete choice theory, with positions did the best. And property C, approximate with positions did the best. So how do we visualize fit here, Dan?
I'm a little surprised by those numbers, because in cases of multiple choices, those mean sum of squared error, I assume that Breyer score choices in situation, you try to validate, right? I mean,
Right.
even if you have a very, very good model, I mean,
Yeah.
that mean squared error score is not going to be very small, actually.
So you think these are pretty small?
They are very small, actually, especially if you look at the property B. I mean, that's very, very small.
Which should be good news, I guess. But I don't have a sense of like what's a good number for.
Because I work a little bit on choice models myself, and
yeah.
I usually see much larger numbers. That's why I'm surprised.
So I'll show you. Maybe this answers that comment a little bit. I'll show you a way to visualize the answers that we get. Predicted probabilities put in bins. Right, so think about like about 500 upsell offers in one bin, and in the next bin another 500 upsell offers, in the next bin another 500 upsell. So if you think about those bins and separated by predicted probabilities, and just and then look at what is the actual frequency of acceptance.
Oh, you're comparing probability, not whether you made the correct prediction.
Yeah, right. So predicted probabilities versus sort of actual shares, and this is property B, and here the exact approximate MNL. So MNL is sort of tapers off a little bit toward the end, right? Property B again, is this again B? So these are rest of the models. Approximate with positions, MNL with positions, and then the company predictions. So we had the company predictions as well, and comparing model versus what was predicted by the company, property B. That's the story. And here's in property C, approximate with positions, which is our kind of best model, I guess, and MNL, the simple MNL, and then MNL with positions, and this is company predictions. Of course, they have some business constraints around those predictions. There are other things going on which we ignore, right? So this is not, I'm not saying this is like a fair comparison, because we're ignoring a lot of practical realities. But our model seems to be doing pretty well given all those assumptions. So this is approximate with positions, MNL with positions, and company predictions on another property. Again, in all of these, multiple choices were ignored. Comment on whether these choices would be correlated or not, and whether why these models would make sense. So first of all, we wanted a scalable model, right? For multiple possible categories, we wanted a scalable discrete choice model so that you can optimize prices and assortment, right? And to the extent that you can capture the common characteristics among these properties through observed properties, if you're doing a good job on that part, maybe the choices would be less correlated. So the correlation issue we're hoping would go away, right? And of course, that's an open question, right? So whether the Coppola approach would pay off better versus this, which one is more sort of scalable in practice, all of these are open, and I'm glad a lot of people are looking at this important problem. So ongoing work, so as I said, this is sort of a part of a dissertation work, and I'm here to report from it. So analysis of the structure of the optimal upsell prices is yet to be completed, right? Now, I want to say one thing about the validity of the demand model and whether Logit is the best way to move forward. Initially, we started with Logit because that's kind of the golden standard in the discrete choice modeling. There are two things that are odd about the MNL model. One is the conditional probability of accepting the offer does not depend on what you picked as your initial choice, which is definitely odd. Now, if you apply a mixed MNL model, you'll probably get away from that. But if you apply simple MNL, that's what's happening. That's one. I suppose. No, it is. But why do you think Markov chain would imply this? Yeah. Markov chain is very hard to interpret, though. So I don't know if it applies even here. Right. And it's very hard to optimize prices with it. Optimal assortment, all products with higher price, you should offer all of it. That's what MNL would say, right? And Natalia just recently figured out that, for example, the exponomial choice model that I had a hand in developing would actually get away from both of these issues. The first one would not happen. Initial choice would matter. And the second one would not happen either. So we are hoping to develop alternative discrete choice models as well compared to logit, and then maybe do a horse race among many of these. So I guess, and of course we want to continue our partnership with Oracle Labs and maybe look at, with other properties and with multiple choices possibly. I want to end with just one thing, that scalability I think is pretty important in this business. So coming up with a simpler structural model that assumes away some of the things like correlation or other things, but at the same time scalable enough that you can optimize price and assortment could actually be more valuable than an exact model that basically replicates a lot of reality. That's all I have. I'd be happy to answer questions on or offline. I don't know how much time I took, so I'll leave it to Andrew to decide.
Let's thank Aydin, and let's declare a coffee break when we can ask him questions.
Sounds good to me. Thank you. Thank you.